we will discuss three questions in this session. It's about the what is electricity, what is the static electricity, and what is the difference between both of them. And we get the concept about the what is electricity, that was actually the flow of the current, and the flow of the current, a flow of the electrons, and the flow of electrons is because and every atom has electrons around the nucleus, and nucleus is the center of the atom, and the center of atom has protons and neutrons inside. Here we have the static electricity. Static electricity is actually the occurs when there is buildup of electric charge on the surface of the material. Okay, like this way here, if there is a surface, there is positive charge or negative charge on the surface, then it means that charge is actually static. And what is the concept of static? Static means doesn't moving. Okay, so the charge that don't move are are discussed in static electricity, and those charges which are moving are directly discussed in electricity. Okay, the static electricity has two types of charges. Number one is positive charge, number two is negative charge. As we know, opposite charges attract each other, so positive negative attract each other, like the and we know the like charges repel each other, like positive positive repelling each other, negative negative repelling each other. So whenever there is static electricity, there must be opposite charge between both surfaces. Like you in your childhood memories, you have the concept of rubbing this plastic scale with your hairs or with your hands, and then you can or with the wool cloth, and then you can attract the paper scrap. So what is the force between both, and what was the phenomena over here? That was the phenomena of static electricity and these electrostatics, because our ruler gets some charge that may be positive or negative, and the other paper scrap get the another charge. So different charges attract each other, and there must be an electric force. So that whole concept of static electricity is based on the concept of charging by friction. Just take a break for azan. Okay, we are starting again. Here we get the idea, like what is the concept behind static electricity? That concept is actually this one. You see, charging by friction, because whenever rubbing something, there is friction. Okay, and that concept is directly linked with electrostatics, that is the branch of physics that deals with the static electricity, is called static electrostatics. And static electricity, in static electricity, we have multiple questions that we can answer. And the first question is, where do the charges come from? So the charges come from due to the unbalance of the number of electrons and the protons. Whenever the number of electrons and protons are equal, there will be net zero charge. And whenever number of electrons are greater than protons, there must be negative charge. And whenever number of electrons are less than that of the protons, there must be a net positive charge. You can see over here in examples 2 I have discussed. And is in question number 2, we see where do the charges come from, like why we are taking into account charges, because they are coming from something. And when a balloon is dropped with a piece of wool, the wool get positive charge because the electrons from wool comes to that balloon, and the number of electrons in balloon get more than that of protons, and it gets net negative charge. And the number of electrons in wool are less now than that of the proton, so it get net positive charge. So both will attract each other. Because there are different charges over here. So we get the idea here. It's question number 3, that is, where do charges come from? Because rubbing the materials, and during rubbing materials, don't say that we have created charges. No, matter can't be created nor be destroyed, so charges are not created but transferred. Okay, charges are just transferred from one to the other surface, that is transfer of electrons. Okay, and we have the examples that you can perform in your home, and you will share the results with me. What do these have in common? That is again friction. Okay, because we are rubbing balloon, our feet are rubbing with the carpet, our clothes are just rubbing with the dryer, so that is friction actually. So static electricity is combining transfers electrons from the hair to the comb by the friction, right? And resulting in a negative charge on the comb and a positive charge on the hair. That is again the concept we have discussed in balloon, because here due to the unbalance of the charges, one object gets negative charge, and the other object gets positive charge. So these both are attracting each other due to the phenomena of same charges attract each other. Induced charge, that is an important concept over here. Charge and neutral objects, right, not touching are attached because electrons move in the neutral objects only. You see, whenever there is a unbalance of the charges, it's at the start that object was neutral, and electrons moves towards the positive charge. That is another important thing. Wherever will be the positive charge in excess, there must be the transfer of the electrons from negative to the positive positive place, and away from the negative charge. That is again the concept of like charges repel each other and opposite charges attract each other. This is called induced charge. Okay, so whenever there is one surface that has positive charge, then it must create a negative charge on the other object, so may they get attraction. Because if it gets the same charge that the first object has, then they will repel each other. Okay, so we get the better picture of static electricity now. And conduction. That was the concepts of induced charges, and now we are studying conduction. Okay, so what is the phenomenon of conduction? Conduction is direct transfer of charge. As we have discussed, that conductors are allowed to conduct electricity, right? But in the concept, in the previous example of the plastic scale, there wasn't any conductor, but there was a static electricity. And a static electricity just not just appears in the non-conductors, they can be appear in the conductors too. So conduction is the direct transfer of the charge. Example: walk across the carpet and touch a doorknob. Shocking. Yes, you got shocked. Why? Why is it happening? Have you ever observed it? Yes, you have observed, and that shocking is because of the transfer of the charge. That is due to the conduction. Okay, the charges you got are just transferred to the metal that was the doorknob, and you got the shock. Okay, electrons are stripped from the carpet and we gain a negative charge. That is the explanation of the conduction, and this shocking, like why we get the shock, because electrons are stripped from the carpet, right, transferred to us. And whenever we get the negative charge, and we get negative charge, and we are touching a metal, that negative charge that is in excess in us will start moving inside that metal. Okay, and because it's conduction and the metal conduct electricity, that's why we will feel a shock. When you touch the doorknob, electron jumps onto it and electrical discharge will appear. Okay. So here we have rules of the static electricity. Number one, objects with like charges repel, but objects with the unlike charges attract each other. That is the rule that is much important, and we have discussed it in our previous examples. And charge objects attract neutral objects. That is a much more important thing. If your comb is uh, positively charged, that will attract an object that is neutral, that may attract that charge, and that may attract the object that is negatively charged. So generally charge objects attract the neutral objects, because they cause the unbalance in that neutral object. Like if uh, your comb is positively charged and your hair have no charge, then the negative charges inside the atoms of our hair will get attracted toward this positive charge, and there must be an attraction force between both. And whenever you are taking a negatively charged object and you comes to an surface that have no charge, then the electrons over the inside the atoms of this object will be repelled away, and there must be a positive charge over here that is got attracted towards this negative charge. So it means due to the unbalance of the electrons, the phenomena of retraction occurs. Now we see, does friction always create static charge? Does friction always create static charge? That is much more important question over here. So we will discuss it in following ways. Different materials have different strength of attraction for electrons. That is an important concept over here. I will ask you to brainstorm over it, and we will discuss it in next sessions, because different materials have different strengths. That's why the attraction for the electrons is different in different objects, right? And you will whenever you will share your results about those activities I have asked you, then we will get the better picture of this conclusion. Static charge form, equal number of the electrons transfer is linked with this, okay, and if we have different objects and they are rubbed, they will definitely get different opposite charges, and they will get attracted towards each other. That is the concept of the static charges build up over there, because one get positive charge and other get negative charge, so they will get the attraction forces between one another. So here we have the uses of the static electricity, that is dust removal, photocopy, car printing, because dust removal concept is linked with the charging one, charging the our blow with the charge that is opposite to that of the dust particles. Okay, so whenever we have opposite charges, the dust particle will be attracted toward our appliance and will get removed. Similarly, photocopier, in photocopy machine, you have studied in your different concepts that in photocopier, the drum get positive charge and the toner gets negative charge. That's why that black toner stuck over this picture and we get the print of of that object that we have put on the lens. And car painting, again we have the electrostatic phenomena over here. We just charge the body of the car with positive charge, and the nozzle of the paint of the electric paint has negative charge. That's why whenever paint is put over the body of the car with the positive charge, it gets stuck over it, and it's long-term paint. Yes. And effect of the materials of the static charge. Materials are listed below according to how well they create static electricity when rubbed with one another, as well as the what charge the material will possess, because it become positive charge, like dry human skin, greater tendency to give up electrons and become highly positive. That's why our skin gets positive charge, leather gets negative charge, glass gets negative charge again. So that there are different materials that gets positive charge and different materials that gets negative charge. You will make a list on your paper and will write which materials get positive charge and which material get negative charge, and that will be your notes for your exams. Okay, so here are some examples from positive charge. And effect of the materials on the static electricity: human hair, nylon, wool, lead, car fur, silk, aluminium, and paper. So these are the positive charge examples, and there must be a different phenomena over here and give up some electrons. These two give up some electrons. So you have to separate out all these examples. You will take this list. Okay, here are three, and here are more examples, and you will take this list and make a difference between both in positive and negative ones, and you will share your results with me. So neutral ones are, there are very few materials that do not tend to be readily attract or give up the electrons, that are the neutral materials actually. And when brought in contact or rubbed together, they show no phenomena, because just like cotton, you feel comfortable in cotton because in winter, in your summers, because it's not get charged. Whenever it's rubbing with your body, it's rubbing with the with our skin, it's not getting any charge. That's why we feel comfortable in cotton. Similarly, steel is a metal that not get charged. That's why we use it in many appliances where we get protected and we want our hand don't get charged. That's why we use steel over there. So becomes negatively charged. These are wood, nickel, copper, gold, platinum, polythene, those who get the negative charge whenever rubbed. And here are here was a discussion about the static electricity, and I am assigning you the another assignment first assignment was to make a list of positive and negative materials. Like the materials those get positive charge generally, and those don't get those that get negative charge. And the other is draw a concept to share your views about the static electricity and conclude in at least 2 lines, like what was your conclusion about the concepts of the static electricity. You have to take an example just like of balloon, rubbing the balloon with the wool, or rubbing the comb in your hairs, or anything in your mind. Like you can take any example and you will observe it and share your results. So may you get the better idea what is the static electricity actually, and what type of material get negative charge and what type of material don't get charged. There was 2 examples that I have shared about the non-static ones. There were many examples about the positive charge. There were many examples about the negative charge. So hopefully you get the better picture and the better idea of static electricity. Inshallah, in next session we will study about another interesting concept, and we will discuss the questions about the session 2. So good luck for your next week, and see you in next week.